Hello friends, myself R.D. Mahajan presenting my video on Stirling interpolation formula. Uh, this video is divided into two parts. In first part, I am going to discuss how that formula is derived for Stirling's interpolation formula, and in second part, I will discuss one simple problem on Stirling's interpolation formula. And to develop Stirling interpolation formula, we take the help of this forward difference table and two results: Gauss's forward interpolation formula and Gauss's backward interpolation formula. Values of x and y are x0, y0 central value, below it x1, y1, x2, y2, above it x minus 1, y minus 1, x minus 2, y minus 2. These are the values of x and y. Then preparing forward difference table as usual. I have discussed in earlier videos. Y minus 1 minus y minus 2 is nothing but del y minus 2. Y0 minus y minus 1 is del y minus 1. Y1 minus y0 is del y0. Y2 minus y1 is del y1. First forward differences. Taking a differences of it, we get second order differences as del square y minus 2, del square y minus 1 and del square y0. Differences of these differences, we get third order differences as del cube y minus 2 and del cube y minus 1, and the differences of this we get fourth order differences as del raised to 4 y minus 2. Then drawing a dotted line for the central values x0, y0, del square y minus 1 and del raised to 4 y minus 2. And for forward, Gauss's forward interpolation formula, we take values like this: y0, then coming downward we get del y0, then again going upward we get del square y minus 1, again coming downward we get del cube y minus 1 and then del raised to 4 y minus 2, zigzag way. And for backward, we have to take the help of this y0, del y minus 1, del square y minus 1, del cube y minus 2 and again del raised to 4 y minus 2. I have underlined all these values. Therefore, we know that the Gauss's forward interpolation formula as, and for that we are taking the help of this 1, 2, 3, 4, 5, 6 values, and therefore we know that result as y of x is equal to y0 plus p into del y0, then p minus 1 by 2 factorial del square y minus 1, next p minus 1 multiplied by p plus 1, this is the additional term, divided by 3 factorial into del cube y minus 1, this value, and next one p minus 1 p minus 2 multiplied by p plus 1 divided by 4 factorial into del raised to 4 y minus 2, and so on. We can extend as per the table. And similarly, we have Gauss's backward interpolation formula as it is y of x. For that we consider the values y0, del y minus 1, then del square y minus 1, then del cube y minus 2 and del raised to 4 y minus 2, and therefore that result is y of x is equal to y0 plus p into delta y minus 1, this one, next p plus 1 divided by 2 factorial into del square y minus 1, next one is p minus 1 p plus 1 divided by 3 factorial del cube y minus 2, next plus p minus 1 p plus 1 p plus 2 divided by 4 factorial into this del raised to 4 y minus 2, and so on. We are calling this as equation 1 and equation 2. Equation 1 for Gauss's forward interpolation formula, and equation 2 for Gauss's backward interpolation formula. Then if you take the average of these two results, that gives you the Stirling's interpolation formula. Therefore, to find Stirling's interpolation formula, we take equation 1 plus equation 2 divided by 2. That is the average of that two results. And therefore, taking the average of left hand side and average of right hand side term. Therefore, yx plus yx, we get 2yx divided by 2. We get y of x as, it is y0 plus y0, 2y0 divided by 2. Then add and then divide by 2. While adding this, we have p common. Then sum of the 2, del y0 plus del y minus 1 and divided by 2, average of that two terms. Then addition of this next two terms and then average of it. Therefore, what is common here? P is common. By 2 factorial is common. Then remaining terms are P minus 1 and P plus 1 in the bracket. P minus 1 and P plus 1. Common is del square y minus 1. Next, sum of these two and then average of that two term, and therefore common is here p minus 1, p plus 1, that term we can take as common. Therefore, p minus 1, p plus 1 divided by 3 factorial. Remaining terms are del cube y minus 1 and here it is del cube y minus 2 and divided by 2. Then adding the last two term and then average of it. Common is 1 by 4 factorial. P is common. P plus 1 is also common. P minus 1 is also common. And the remaining terms are P minus 2 and P plus 2. P minus 2 and P plus 2 divided by 4 factorial. Average of these two and common is del raised to 4 y minus 2. Then taking the average of that equation 1 and equation 2, and after simplification we have a new result. Y of x is equal to y0 as the first term, p by 2 del y minus 1 plus del y0 as the second term. Next one is p square by 2 factorial del square y minus 1, del square y minus 1. Next, p multiplied by p square minus 1 by 3 factorial into average of these two terms, that is del cube y minus 2 plus del cube y minus 1 by 2, and lastly p square multiplied by p square minus 1 divided by 4 factorial into this del raised to 4 y minus 2, and so on. Therefore, we have to use these values y0, del y1, del y minus 1 and del y0. Next, del square y minus 1. Next, del cube y minus 2 and del cube y minus 1. And lastly, the value of del raised to 4 y minus 2. Therefore, whatever this formula, that formula is called as Stirling's formula. Then we try to see one simple example. I will discuss one simple example on this Stirling's interpolation formula. Let us try to solve the problem. Use Stirling's formula to find y at 1.21 for the given data. The values of x are 1, 1.1, 1.2, 1.3 and 1.4, a difference of 0.1, and the corresponding values of y are 0.84, 0.89, 0.93, 0.96 and 0.98. The value at which we require is 1.21, which is somewhat near to this 1.2. Therefore, we call this as x0, next one as x1 and x2, above it x minus 1, x minus 2, and the corresponding values are y0, y1, y2, y minus 1, y minus 2. And then preparing a forward difference table. Therefore, taking a difference of these two, 0.89 minus 0.84, we get that value as 0.05. As del y minus 2, then y0 minus y minus 1 is del y minus 1 as 0.93 minus 0.89 as 0.04. Next, y1 minus y0 as del y0, and that value is 0.96 minus 0.93 as 0.03. Then y2 minus y1 as 0.98 minus 0.96 as 0.02. These are the first forward differences. Taking a differences of these differences, we get second order differences as 0.04 minus 0.05. We get that value as minus 0.01. 0.03 minus 0.04, again minus 0.01. 0.02 minus 0.03 as minus 0.01. These are the second forward differences. Differences of these differences, we get third order differences as minus 0.01 minus 0.01. That value becomes 0, as same values we have, and minus 0.01 minus of minus 0.01 as once again 0. Third order differences is 0. Fourth order differences is 0 minus 0. We get that value as 0. Then we underline the central values x0, y0, then del square y minus 1 and del raised to 4 y minus 2. These are the, if we try to draw a central line, then we take the values below it, means del y0 we require, then del square y minus 1, then del cube y minus 1, and then del raised to 4 y minus 2. For forward differences, Gauss's forward differences, and for Gauss's backward we require this y0, del y minus 1, then del square y minus 1, del cube y minus 2, and finally del raised to 4 y minus 2. Then we try to find the value of p, where p is given by x minus x0 by h. The value of x is 1.21, x0 is 1.2, and h is difference of that two values, between two values, that value is 0.1. Therefore, this one is 0.01 divided by 0.1. If we calculate that value, we get that value of p as 0.1. And then applying Stirling's formula, we get y0 plus p by 2, average of these two, del y minus 1 and del y0, then p square by 2 factorial into del square y minus 1. Next one is p square minus 1 divided by 3 factorial, average of these two values, del cube y minus 2 plus del cube y minus 1, and lastly p square minus 1 divided by 4 factorial into this del raised to 4 y minus 2. And then substituting values from the table, y at 1.21 is equals to, we have the value of y0 is 0.93, value of p is 0.1 by 2, sum of these two values, therefore that values are 0.04 plus 0.03 next is del square y minus 1. Therefore p square, p is 0.1 square divided by 2 factorial, del square y minus 1, the value of del square y minus 1 is minus 0.01. Next one, del cube y minus 2 and del cube y minus 1, as that two values are 0, this term becomes 0, therefore that term becomes 0. Next one is del raised to 4 y minus 2, that value of del raised to 4 y minus 2 is also 0, and therefore this complete term becomes 0, and so on. Simplifying it, we get that value as 0.93, 0.04 plus 0.03, we get 0.1 into 0.07 divided by 2 divided by 2. Then this one is with minus sign. 0.1 square is 0.01 into again 0.01 and divided by 2 factorial. 2 factorial is 2. And simplifying this by calci, we get that value as 0.93, 0.7 into 0.1 into 0.07, it becomes, and divided by 2, that value is coming as 0.04, 0.004, .1 into 0.07 divided by 2, that value is 0.004, and minus this one is 0.01 into 0.01, 0.0, ultimately it is 0.000, and therefore addition of this all values 0.934 4 as the required answer. Therefore, value of y at 1.21 by Stirling's interpolation formula, it is 0.934. We cross check it. For 1.2 it is 0.93 and for 1.3 it is 0.96. 1.21 is in between these two values. Therefore, answer must be in between 0.93 and 0.96. Yes, that value 0.934. It is in between 0.93 and 0.96. Therefore, whatever the value I have obtained is the correct one. One more I will discuss in my next video on Stirling interpolation formula. If you are watching my videos, please like, share it, as well as subscribe to my channel to get a notification for my new videos. Thank you.